Hey guys, today we're going to be talking about valued risk and the importance of it and its comparison to expected shortfall, as well as some formulas through Excel. So the bank management must have methods and techniques in place for reducing risk. According to the 1996 amendment to the Basel Capital Accord, it requires commercial banks with significant trading activities to set aside capital to cover the market risk exposure in their trading accounts. This amendment pretty much requires banks to calculate VaR, which is a big reason why it's so important to them. The United States adopted this amendment in 1998. In the banking sector, the risk must be considered as an interdependent risk, complexity, being possible to have common causes or producing other risks. Considering the importance of market risk, its evaluation is necessary to each bank applying the current measurement methods. So looking at the definition of value at risk is potential loss. Potential losses can theoretically extend to the value of the entire portfolio. In that way, VaR is the maximum loss in a certain period at a preset confidence level. The confidence level is the probability that the loss exceeds the upper bound. VaR is not always the worst possible loss. Loss equal to the size of VaR are expected to happen several times per year and is therefore not equal to capital. VaR is also the value that can be expected to be lost during severe market fluctuations. Severe loss is defined as a loss that has 1% chance of occurring on any given day. It is the expected loss to be exceeded with X% probability in a certain period of T days on the portfolio of credits measured. So expected shortfall is also known as the conditional value at risk, or CVaR. It is a risk assessment measure that quantifies the amount of tail risk in an investment portfolio. Tail risk is the risk that an investment will move more than 3 standard deviations away from the mean is greater than what is shown in a normal distribution. It also includes events that have a small probability of occurring and they occur at both ends of a normal distribution curve. CVaR is derived by taking the weighted average of the extreme losses in the tail of distribution of possible returns beyond the VaR cutoff point. It is used in portfolio optimization for effective risk management. So now we're going to discuss the difference between VaR and CVaR. The standard VaR is often interpreted as the worst outcome under normal conditions over a specified period of time. For example, for a given month, the VaR is at $1 million at 95% confidence level. This can also be interpreted as, under normal conditions in 95% of the months, we expect to lose no more than $1 million. On the other side, expected shortfall, or CVaR, is the exposed loss given that the returns are already below the pre-specified worst-case scenario. For example, below the 5th percentile, therefore, it represents the mean loss among the losses falling below a certain threshold.
Now we will demonstrate how the historical simulation method is used to evaluate VaR. The historical simulation involves using past data as a guide to see future trends for a currently weighted portfolio. To complete this simulation, we will be calculating VaR using a 1-day time horizon, a 99% confidence level, and 501 days of data. The histogram on the right demonstrates the visible valuation of the historical simulation. As you can see, the historical daily returns have been plotted to show maximum returns and maximum losses over a given period of time, as well as the frequency at which they occur. At the bottom left, you will see the losses for the range of data. These losses represent the worst 5% for a confidence level of 95, or the worst 1% for a confidence level of 99%, which is what we will be using in the example coming up. To illustrate the calculations underlying the approach, suppose that an investor in the United States owns on September 25, 2008, a portfolio worth $10 million, consisting of investments in 4 stock indices: the Dow Jones Industrial Average in the United States, the FTSE 100 in the UK, the CAC 40 in France, and the NIKKEI 225 in Japan. The value of the investment in each index on September 25, 2008 can be seen on the next sheet 2 scenarios, in the upper right-hand corner. The first step is to identify the market variables affecting the portfolio. These market variables are sometimes referred to as risk factors. They typically include exchange rates, interest rates, stock indices, volatilities, and so on. Data are then collected on movements in these market variables over the most recent 501 days. This provides 500 alternative scenarios for what can happen between today and tomorrow. Here you can see the indices that we have collected for 4 different stocks. Before moving forward, we must convert the indices into US dollars. We will do this for each by taking the exchange rate from August 10, 2006, which in this case is 1.8918 US dollars per GBP. So, with this done, it's now equivalent to 11/16/71, and we now have the data required to perform the simulation and can move forward. The next step is to calculate the value of each stock under Scenario 1. Here you can see the algebraic explanation. We take the value of the stock on September 25, 2008, and then we multiply it by the value of the stock on August 8, 2006, divided by the value of the stock on August 7, 2006. This gives us, after our calculation, the value of the stock under Scenario 1 at 10,977.8. We will copy this down on our spreadsheet for all 501 scenarios for each of the 4 indices in the portfolio. We will then calculate the value of the portfolio under each scenario. The formula is as follows: multiplying the value of each stock under Scenario 1 by their weight in the portfolio. Thus, the value of Scenario 1 is 1014.334. Here is a shot from our spreadsheet showing the value of each stock under the first 30 scenarios, and as I said before, it continues down through 501, and then you can see on the right side under portfolio value, we have calculated the portfolio value according to each stock's value based on their weight in the portfolio. We then will calculate the loss of the portfolio under each scenario. This is completed by taking our new portfolio value, so for Scenario 1, the value of $10,14.33 minus the original $10 million investment. So this results in a gain of $14,334 under Scenario 1. We will then copy this down again on our spreadsheet for each of the 501 scenarios. So the data on this spreadsheet is from Yahoo Finance. It's for the S&P 500 adjusted close, and it is for the past 250 days. First, we will calculate the return. To do this, we will divide the adjusted close from the current day by the adjusted close for the previous day, and then subtract 1. You will format the value to a percent and then copy down for each date of the data provided. It's the formula that you'll copy down to get the return for each day. Next, we will calculate the mean. This is simply an average of all of the returns for the portfolio data. In this case, you simply will take the average of the column H. The mean is equal to 0.54%, thus being the average percent return over the last 250 days for the S&P 500. We then will solve for the standard deviation. Excel makes this simple as we can use the function stdev.s. Click on cell I3, enter an equal sign. After the equal sign, you'll hit stdev.s. The formula will appear. And then you'll enter the data group, in this case being H3 through H252, and close the parentheses and press enter. The standard deviation will be equal to 1.05% for this portfolio. Now we are going to determine VAR. We will use a confidence level of 95% to do this. In Excel, you will use the norm.inv function. So click a cell and enter an equal sign, type norm.inv and the function will pop up. For the data, we will enter 5%, comma, I2, comma, I3, and close the parentheses and press enter. We can now see that var is equal to negative 1.19%. This tells us that at a 95% level of confidence, the maximum loss for this portfolio is 1.19% and will not exceed any further.